Okay, today we're going to talk about the net change theorem. A net change theorem discusses, well, here's a way to think about it, okay? If I have a position function, do you remember what happens if I take the derivative of the position function? Velocity function. So v of t is equal to s prime, or s prime of t. Remember when we did that? And then if you take the derivative of velocity, you get acceleration. So a of t is equal to v prime of t, or s double prime of t, second derivative. Agreed? So what we've learned over the past few days is that this integral symbol, it really means we take the antiderivative of whatever sits inside of there, right? Okay. So a cool thing regarding this piece is that all we've done is we've usually written it like this. The integral of a to b of f of t dt is equal to big F of b minus big F of a. That's the fundamental theorem of calculus part 2. And we all know how to evaluate that, right? Spent a lot of time doing that. So here's the difference, and here's what you want to focus on. The antiderivative of f is big F, right? The antiderivative of f prime is just little f. So what it means is that when we want to figure out the net change, we take the antiderivative of the derivative. In other words, hi. Let's think of a derivative in this situation. The derivative of s of t is v of t. So therefore, if you did the integral from a to b of v of t dt, you would get s of t, s of b minus s of a. And what that means is very simple, okay? If I want to figure out the displacement of a function, we used to have a way in figuring out how to do that. We would like figure out when did it change direction, and where was its location, and everything like that. Remember when we mapped out this guy? We said, well, it's going to go here, and then back here. Remember when we did that guy? Yeah. And part of what we want to figure out is, well, what's the total distance it traveled? That's part of what we want to figure out, right? But something else you might want to figure out is, like, what's the actual displacement of the object? Where is it from where it started? Well, all you have to do is just take the integral of the velocity function, and it tells you the entire displacement. It's really cool, and it's really simple. Watch this example. A particle moves at a velocity modeled by this function. V of t is equal to t squared minus t minus 6. So instead of being given the position function, you're given the velocity function. It says t is measured in seconds and v is measured in meters per second. Find the net change, or the displacement of the particle, over the interval 1, 4. So in order to figure out a, all I have to do is the integral from 1 to 4 of t squared minus t minus 6 dt. Before we actually do the integral, I want to show you what we used to do. We used to look at this function and say, well, it's t minus 3 times t plus 2. Everybody agreed? What shape does that make if I graph it? A parabola. And it goes through the points -2 and +3. So it looks like that guy right there. So is the particle traveling in the positive direction or the negative direction right here? The negative direction. Why? Because it sits below the x-axis. The velocity is negative. Now, D. Weiland, you're right, the derivative is positive. But we're talking about the velocity. The velocity is negative as it sits below the x-axis. Is the particle traveling in the positive direction or the negative direction here? Positive, because it sits above the x-axis, right? So from 0 to 3, the particle is traveling to the left. And then once it gets to 3, it turns around and starts traveling to the right. That's what the particle is doing. So what we used to do is we used to say, well, let's figure out where it is there. And then let's figure out where it is there. And then let's figure out where it is there. And we'll come up with like the total distance that it's traveled. Okay? That's what we used to do. Well, what we are going to do now is we can't tell by doing this exactly what the distances it traveled, but we can figure out how far is it from where it started. Okay? We can say, is it further to the right? Is it further to the left than when it started? Is it 1 unit to the right? Is it 2 units to the right? How far is it from where it actually started? In order to do that, this is all we need to do. 1 to 4 t squared minus t minus 6 dt. What's the antiderivative of t squared? What's the antiderivative of t? T squared over 2. Antiderivative of 6. I can evaluate it at 4 and at 1. So, looks like here if I plug in 4, I get 64 over 3 minus 8 minus 24 Now what do? I plug in 1. So if I plug in 1, I get a third minus a half minus 6. Very good. Now everybody has their different way of operating here. This would be a question on the AP exam where they maybe say, hey, you don't get to use a calculator. 64 thirds minus 1/3 is 63 thirds. Agreed? What is 63 divided by 3? 21. So I've gotten rid of those. 21 minus 8 minus 24. I'll be plus 1/2 and plus 6. Looks like I can combine some things here now pretty easily. 21 minus 8, 13. 13 minus 24. Negative 11. Negative 11 plus 6. Negative 5. Negative 5 plus 1/2. Negative 4.5. Or negative 9/2. Thank you, Chris. We're going to put a label on that. I want you guys to look at our actual graph here. We have the integral from 1 to 4. Okay? From 1 to 4. Does it look like I have more negative area or more positive area? I would have more negative area. So you can see that it traveled more in the direction to the left than it has to the right. Therefore, I am negative 9/2 meters from where I started. So if I started here, I went back to the left and I turned around to the right, but I never actually got past my starting point. Okay, I'm further to the left than I was to the right. Okay, is that okay so far? 99% of the time, yes. But they will do questions like this on the AP exam. They will say, okay, we're going to go 3 to 4. And we learned that you can flip that and go 4 to 3. What do you have to do then to the integral? Make it negative. So, but for your purposes, you will always put the number to the right on the top and the number to the left on the bottom. Okay? All right, then all we want to do is we want to try example B. I'm going to let you start working on your worksheet and work through this. It says find the total distance the particle traveled over the interval 1 to 4. Well, we need to really think about this for a second in order to Okay, so in order to figure out the distance traveled is going to be as follows. The integral of the absolute value of the velocity function from 1 to 4. Now, on the AP Calculus exam, There's times where you can actually write that down in your free response, and you get like 2-3 points just for writing that, okay? Sometimes I struggle to get students to write that piece down. As long as you remember distance is the absolute value, whereas displacement is no absolute value, that's going to get you a bunch of points. The difference is that many times the AP Calculus exam, they allow you to use a calculator. We're going to actually do this by hand here, okay? We're going to do it by hand. I know it sounds really bad, but we're going to make it super simple, okay? So we're going to do the integral of the velocity function, absolute value, 1 to 4, all right? In order to do that, we have to consider the negative area and the positive area. Tell me, where does it change from negative to positive? At 3. So we're going to break it up into 2 integrals. We're going to break up into the negative area, and that would be from 1 to 3. That's how far it's traveled in the left direction. And then we're going to do another integral. We're going to do the positive area, or how far it traveled in the right direction. And that will be the integral from what to what? 3 to 4. Very good. T squared minus t minus 6 dt. Brenda will get your pass. Okay, here we go. T cubed over 3 minus t squared over 2 minus 6t evaluated 3 and 1. Plug in 3, what do you get? Yep, 9 minus 9 over 2 minus 18. Minus, now what? 1/3 minus 1/2 minus 6. Ugh. Oh well. We'll figure it out. No big deal. Ready, Gigi? You're born ready. You look awake. You look like you slept good yesterday. Good job. All right. 9 minus 18. -9 minus -6. So I would add 6 and I get. I got -3 if I get rid of those guys. I got -9/2 minus -1/2. So it would be a -4. And then minus 1/3. So I got -3 minus 4 minus 1/3. Oh, wow. Good job. So -7 and 1/3, which is -22 over 3. We knew our answer should be -y. Because that's where, as you looked at the graph that we checked out right here, we said that's the negative portion where it's below the x-axis, where it's traveling in the left direction. So that means it was displaced 22/3 in the direction to the left before it started traveling to the right. But when we count, total distance traveled, we count that as positive, right? So that's what it means to take the absolute value. So we'll count that as positive, but let's first do this next one, and then we'll add it together and be done. We have t cubed over 3 minus t squared over 2 minus 6t evaluated 4, 3. Plug in 4, what do we get? 64/3 minus 8 minus 24. Does that look familiar? Yeah, you used it before. Then we plug in 3, and I get 9 minus 9/2 minus. Does that look familiar? Yeah, you've used it before. You can see where it comes from. All right, well, let's do some work here. Negative 8 minus 24 is negative 32 minus 9, negative 41 plus 18. Negative 23. So I got rid of that, and that, and I got a negative 23 out of the deal. Plus 64 over 3 plus 9 halves. Common denominator? 6. 23 times 6, 132. Negative 132 over 6 plus 128 over 6 plus 27 over 6. Question? Oh, thank you. Louder next time. That way we don't make a mistake. Negative 138 plus 128. Negative 10 plus 27. 17. I came over with a positive. Are you surprised it came over with a positive? No, because we said that's the distance it's traveling in the right direction. So if it traveled negative 22 thirds in the left and it traveled 17 over 6 in the right, then we're simply going to take those two and add them together. 22 over 3 plus 17 over 6. Common denominator of 6, so 44 over 6 plus 17 over 6, and I get 61 over 6, or 10.16 repeating. Yes? I will not give you guys a no calculator test, but there will definitely be a section on the AP practice test where you will not be able to use a calculator. Yeah, because we're going to do the absolute values. We're going to count both as positive. You travel that in the negative direction, that in the positive direction. Take out your calculator. Let's verify our answer. Because we said from the beginning that we're going to take the absolute value. So we're going to take that area that was negative and we're going to make it positive. I'm going to type in x squared minus x minus 6. And I'm going to second calculate. And I'm going to go number 7. And my lower limit, we're going to count as 1. My upper limit, we're going to count as 4. And look at the result I get. I get negative 4.5. Was that our first result? It was. Now, I'm going to show you how to check the second one. Y equals, and I'm going to insert second catalog absolute value. The function, do the integral. Yep, that's it. Now, if I check the absolute value and I calculate this, I'll go zoom 6 so you can see the graph. Look at what it does to the graph. It takes that portion where the parabola went underneath the x-axis and it flips it up. See that? So it's going to count that area that we counted as negative. It's going to count that as positive now. Your calculator is able to do that, which is pretty cool, right? So we can calculate number 7. We go from 1 to 4. We should get 10.16 repeating. Calculator is not as smart as we are. We're smarter. No surprise. And that's that. So there is a lot more to the net change theorem. This is the kind of the raw look at it, but without a doubt, over the course of the next couple days, we are going to look at net change theorem along with mean value of a function. We're going to look at some AP type problems. These are straight really out of the AP exam, and you're going to become very familiar with it. question like this, velocity cars modeled by velocity equals 20 sine of pi t over 2 minus 1, where t is measured in hours, v is measured in miles per hour. Consider v of t over the interval 0 to 4 and let s of 0 equal 10. This represents the most common free response question that's ever been asked on the AP exam. So I can just about guarantee that you'll be asked this question. And furthermore, when you get to our practice test, I will expect, my expectation is that on the AP exam, all of you would get at least a 6 out of 9 on this type of question. At least a 6 out of 9. There are 6. Each one's worth 9, total 54 points. It's half your exam. 2 of them are calculator allowed. 4 of them are no calculator allowed. This would be a calculator allowed. This one you really can't do without a calculator. Okay. So, but, all right. I'll hand you guys your assignment. We'll get started on the easy stuff first, and then we'll get to the more difficult stuff in a little bit.